Assalamualaikum and greeting I bid to my supervisor Dr. Tamiru Ali Mulema, lecturer of Mechanical Engineering Department, Dr. Tuan Muhammad Yusof Shah Tuan Ya, internal examiner for my research proposal defense. Introducing myself, I'm Muhammad Dinie Hardani bin Wardi from Mechanical Engineering Department. For this presentation, I will present the proposal of my final year project research, which is the performance evaluation of the volute heat exchanger. So for this presentation, I will cover on 7 subtopics. The first one will be the introduction of the project. Second one is the problem statement, hypothesis, and research question for this project. The third one is the project objective and that would like to be achieved throughout the project. And then we will be discuss the project scope and the relevant literature review. Lastly, the methodology means the planning of the project, including the key milestone of the project. Okay, and as I mentioned before, my project will cover on the performance analysis for volute heat exchanger, which is relate to the heat exchanger as general. So what is heat exchanger? Heat exchanger is a device that allow heat from a fluid to pass to another fluid without the two fluid having to mix or come into direct contact. Various type of the heat exchanger is utilized in various kind of the application, such as in the processing food, automobile radiator, condenser, and air preheater, cooling tower, and many more. So there are several type of the heat exchanger that have built over the last decade that can be classified in a variety of ways, such as the tube heat exchanger, helical heat exchanger, plate heat exchanger, spiral heat exchanger, and the others. So due to force convection in the heat exchanger, the cooler fluid gains heat from the heat fluid that and as it allow the fluid flow alongside or across it. Okay, for this design purpose, I will develop the heat exchanger based on the volute design that being called the volute heat exchanger. For this design, the design volute heat exchanger is based on the conical coil heat exchanger, which a combination of helical coil and spiral coil configuration, and as shown on the figure beside. For this, for this volute design, I will be using the rectangular coil tube that will conduct the passive heat transfer enhancement technique in the heat and mass transfer application, because it will create the secondary flow in the coil that will improve the heat transfer rate coefficient. So based on my research that I've been done before, that have been done, some of the researchers suggesting that the cone cylinder spiral coil will offer the superior thermal performance to the heat exchanger. So based on that, my project will be more focused on the research performance of the volute heat exchanger design, which is to optimize the compactness and provide high performance efficiency to the current design heat exchanger. Next, moving on to the problem statement. So the main purpose why this project and research have to be done and have to be conducted, because of the volute heat exchanger model, and is a brand new design concept that hasn't yet to be explored and tested by the most of the researcher. Therefore, by conducting the research, it might be the worthwhile discovery in order to develop high efficiency and heat exchanger for the future. So the hypothesis for this project research is the volute heat exchanger has better thermal efficiency as compared to conical heat exchanger. The research question that may arise from this project are, first, what are the optimum dimension for the high efficiency of heat exchanger. Second, what is the correlation characteristic among the manipulate variable and the response of the heat exchanger. And lastly, what is the boundary condition and meshing grid number need to be set to achieve the valid and the most accurate result. Based on the problem statement, hypothesis, and research question before, I may conclude the main objective of the end goal for this project are firstly to investigate the effect of geometry parameter such as the coil dimension, thickness, and other parameters on the heat exchanger performance by using computational fluid dynamics (CFD) simulation. And the second objective for the project is to develop a predictive heat exchanger model for the performance and efficiency heat exchanger. So next is a project scope. This is my scope of my project. In order to develop the volume heat exchanger model and CFD simulation, some important factors need to be considered, such as the design of the coil, shell of the heat exchanger, the type of meshing and grip, Reynolds number, volume flow rate range, and the fluid type that will be used in the research. For the simulation process, I will be use the Fusion 360 application to develop the CAD model, and I will use the Altair Hypermesh for the CFD simulation. So some parameters that we record from the simulation, such as the pressure drop, heat transfer coefficient, and another related parameter to make a predictive model development. Okay, for the relevant literature review, there's about 10 and more article and journal that I be reviewed, but I have include the 10 article that have the most accurate and related for my project research. So this is the reference. Okay. So I will just explain the summary from those reference. So based on the literature review that I be referred, most of the reference and researcher were emphasized on those criteria, which is the performance drops, thermal performance of the heat exchanger, and the effect of the dimension parameter to the heat exchanger. So for example, the article number 10, it is mentioned about the thermal performance and the effect dimension parameter to the heat exchanger, which are, it says when the coil turn number increase, so the heat exchange, the heat exchanger area also increase. So when the area increase, it will also increase the heat transfer efficiency, because more fluid will have contact to the surface area of the coil. So based on that, it will provide me some ideas and insight, since I need to determine the best model dimension in order to get a quality and good certified result from for the simulation. In other hand, there are also reference that I've been referred to be as my database and methodology reference, and in order to get the valid model dimension and the overall planning process to conduct the CFD simulation, such as from the reference number 1, 2, 6, 7, and 10. Moving on to the methodology, so this is overview flow for my project. In FYP1, and I will cover the literature review and identify the problem statement and objective. Next, I will setting scope of a project and assign the database to refer. Then I will develop the CAD model for the volume heat exchanger design. Done in FYP1. In FYP2, I will continue to generate the meshing and grid from the CAD model. After I get the valid meshing result, I will continue to develop the CFD simulation. Then come to the crucial part, which is to compose the result and do the predictive model development. And then lastly, I will finish up the project and proceed to project documentation. So this is the flowchart. It will explain more detail about my project flow. In order to I get the accurate and quality result, some parameters need to be real question and confirm before proceeding to the next step. So if the step doesn't meet some requirement, it needs to be amend and rectify until the requirement is met again. So this is the flowchart. Next, moving on to Gantt chart. This is the expected due date timeline for every task in my project. So basically, there are 3 key milestones that I need to be achieved for this project. Firstly, to complete the CAD model development for the volume heat exchanger. And second, completion of the proof of concept, which is the final CFD simulation result. And then lastly, I will complete the predictive model and do the project documentation. So for your information, I'm currently in process to prepare the develop the CAD model for the volume exchanger, and I may proceed to the simulation after I get the valid design dimension. So I think that's all for my presentation. This is the reference that I've been referred to complete this slide presentation. I think that's all from me. Thank you very much.